Okay, here is a really scary looking summation. However, once you've learned the limit comparison test, you realize that for the convergence of a series, we really care about what happens when n is really big, right? So what happens to these sequences when n is really big? Well, you can kind of ignore -2, +3, +1, and +5 when n is really big, right? So this thing is somewhat like 3n times n squared, and then you can cancel one of the n squares out. So this really complicated looking series is really something like 3 over n squared. Now, would it converge or diverge? It converges, right? Summation of 1 over n squared is a p-series with p equals to 2, so it converges. So that's what you want to use. You want to use the p-series with 1 over n squared.
If you couldn't see that, then how would you do it? Then?
You have to see it. That's
otherwise, you
you're
close.
Yeah, that's actually the challenge, right? Okay, so solution. Summation of n equals to 1 through infinity of 1 over n squared converges. It's a p-series with p equals to 2, which is greater than 1. It's this one here. And then we say limit n going to infinity of 3n minus 2 n plus 3 over n squared plus 1 n squared plus 5. You take the ratio between the given sequence with what I want to compare with, 1 over n squared. And then, keep, change, flip, right? Keep the top, change the division to multiplication. This division became multiplication, and you flip the 1 over n squared, so it's n squared over 1. You're still taking limit n to infinity. And you can kind of already figure out the limit here. See, the highest order term is 3n times n squared. What's that? 3n to the 4th. Right? How about the bottom? N squared times 1? N to the 4th. So what's the limit?
4.
No.
Oh, 3.
3n squared over n, 3n to the 4th over n to the 4th, so it's 3. So the limit will be 3. You can just write 3 there if you know that. Or if you don't know that, you can continue on and say n squared 3n minus 2 n plus 3 over n squared plus 1 n squared plus 5. And then you learn that in order to find the limit of such a thing, you have to divide by the highest power, which is n to the 4th power. So we're going to divide top and bottom by n to the 4th, which tells you that limit of, first of all, n squared cancels. So you still have n squared to divide. We'll just divide this one by n, this one by n. So that's going to give you 3n over n minus 2 over n, n over n plus 3 over n, over n squared over n squared plus 1 over n squared over n squared plus 5 over n squared. Since I'm dividing this one by n squared and this one by n squared, I am dividing by n to 4th in total, okay? This one's 1, this one's 1, so what's the limit? It's a limit n going to infinity of 3 minus 2 over n, 1 plus 3 over n, over 1 plus 1 over n squared, 1 plus 5 over n squared. And all these are 2 over infinity, 3 over infinity, 1 over infinity, 5 over infinity. Those are all zeros, right? So you end up with 3 times 1 times 1 times 1, which is 3. And indeed, that's not equal to 0. So our limit comparison test says if such a thing happens, then, and if this other one converges, then this one converges as well. Right? So by limit comparison test, summation of n equals to 3 to infinity of 3n minus 2, n plus 3, n squared plus 1, n squared plus 5, converges. So that's simply the idea. So here, I guess the lesson here is that when you see something complicated, try to get rid of the less important things and try to judge the behavior of the series. This behaves like 3 over n squared, of course. It says 1 over n squared converges, this should converge as well. That's the idea of the limit comparison test.